Ladies and gentlemen, good afternoon. Now, if you were with us this morning, you'll know exactly, obviously, why you are here and what you are doing here. Those of you that perhaps were not here this morning or round about the front entrance, they're not sure whether to come in, to stay out or come in, stay out or come in. Well, we advise you, yes, to come on in because, again, if it's innovation you're looking for, if it's big ideas, if you're looking for a little bit of inspiration or simply just to kind of get a feel of really what the temperature is in terms of the innovation that's out there right now, those big ideas starting to shake up the industry, you're certainly in the right place because we are about to jump into, once again, a whole session all about big ideas. So this is the Startup Booster competition, the leading competition within the composite industry. And as I say, it's all about big ideas in this industry. This morning already we listened to 10 different ideas from the product and materials category, 10 big ideas. We'll find out tomorrow who the winner is of that category. Right now, over the next 60 minutes or so together, it's all about process manufacturing and equipment. That's the category we're jumping into now. We have 10 big ideas, 10 startups. We have a jury of distinguished jury members, and they were with us this morning, and they will decide the fate of our startups, the fate of who walks away a winner. Remember, we are looking for one winner from this morning's category. Right now, this category here, we will have one winner from that category, and there's actually one other category as well, the best sustainable solution. So we're also looking for the best sustainable solution. As you listen and as you view, I'm sure in your minds you will evaluate yourselves, but hey, I have to tell you, your opinion doesn't count. Mine doesn't count either, but what does count are our jury members. You can see behind me on the screen, these are our jury members. We thank them, very privileged and honored to have them with us. Naturally, also our partners in this project, moving it forward as always. So Airbus and Owens Corning, together with Mercedes-Benz, thank you so much. How does it work? It's very simple, very easy to comprehend. Well, you don't have to do anything. All you have to do is sit there and watch 5 minutes, right? So standing here or on the stage for 5 minutes, sharing their big idea. Then 2 minutes, up to 2 minutes with our jury members, giving them a chance to ask the questions perhaps that no one else dares to ask, to find a little bit more about how these startups, how they tick, and more about the concept, and even about the actual founders themselves. You'll see how it goes. Very simple, very easy to comprehend. It's quite exciting. And let me tell you this as well. Afterwards, once you've heard everybody, I'm sure some of them, perhaps all of them, you'll be curious, you'd like to know more. You'd like to perhaps challenge some of the ideas that you hear on stage. They're here for the same reason you're here as well, for conversation. So you can come up to them straight after this startup pitching session, or you can meet all of them at some stage today or tomorrow or the next day at the Startup Booster Village. The Startup Booster Village, that's essentially coming into this hall number 6. You'll find at the entrance a whole area with all their booths. There's coffee, there's snacks. I think there's nice croissants over there. You can sit down, have a chat, and really get to know really what these startups are about. Because again, everybody's here for conversations, them, you, and everybody else. Shall we get going with the first starter? I think we will. Let's see. So, once again, process, manufacturing and equipment, our first startup. And again, this is a global competition. So right now, we go over to Germany. Please welcome on stage our first startup called CarboScreen.
Yeah, hello everybody. We are CarboScreen, an engineering company from Aachen, Germany, and our mission is to make carbon fiber production cheaper and more sustainable with digitalization. I'm pretty sure you're all familiar with the benefits of using carbon fibers in carbon composites, but let's have a look at the current carbon fiber market situation though. So in the last year, we had an all-time high in carbon fiber demand, and over the next years, the growth rate is expected to remain strong, over 10%. So overall, it's a very positive development in carbon fiber. But if you compare the demand of carbon fibers to other materials such as glass fibers, aluminum or steel, we see that the carbon fiber market is still in its infancy. So we ask ourselves, why is the carbon fiber market so small? What prevents carbon fibers from being used in high volume applications? To answer these questions, we have to take a look at the production process. So carbon fiber production is a complex, multi-stage thermal conversion process of a polyacrylonitrile precursor to a carbon fiber. And in this process, the oxidation step is the most significant step because it significantly determines the properties of the resulting carbon fibers. And due to its exothermic nature, can cause fatal fiber damage or equipment failure. In an industrial process, we have several hundreds of fibers which are processed simultaneously, each fiber consisting of thousands of filaments that are processed over a distance longer than 1 kilometer at an average speed of 12 meters per minute. And the problem here is that this complex operation is only monitored only manually by a few operators. So it's easy to understand that we have a lot of fiber damage in the process. But the story is not over yet. There are also exothermic reactions that have to be overseen by the same operators. Otherwise, the fiber could catch fire, or even in the worst case, the ovens could explode. So I think we can all agree that the manual monitoring in carbon fiber production is a bottleneck. So the answer to the question for the beginning is that carbon fibers are produced using low performance equipment, which then again leads to high costs and process limitations. And we as CarboScreen want to overcome these issues with digitalization. So sensor systems like our optical sensor in combination with an AI image processing unit that is able to detect various types of fiber damages with accuracy of higher than 99%. That is suitable for all kinds of fibers, not only precursor fibers and carbon fibers. That is validated in a lab scale, and that is currently in the process of being scaled up to an industrial scale with our first customer. So besides this optical sensor, we are also working on a second sensor, which will determine the exothermic reaction, which will monitor the reaction process. And the first sensor will be marketed for ready launch in 2025, and the second in 2026. So what's the impact of using our systems? By using our CarboScreen technology, the manufacturer is able to increase his productivity by, for instance, 25%, which means he can lower his costs by 11%, have 13% lower CO2 emissions, and at the same time increase product quality and process reliability. And as a next step, we want to transfer our experience from the carbon fiber manufacturing process to develop sensors for other fiber manufacturing processes and composite production processes. But today our target market is carbon fibers, where we want to sell our sensors plus customized software for retrofitting existing carbon fiber production plants and equipping newly ordered plants. And by doing this, we expect our revenues to be 12 million euros in 2029. Our approach has already been valued by industry experts, as evidenced by our exist funding and several rewards that we received in the last year. Our team consists of 3 founders that know each other for a long time from working as doctoral candidates in the carbon fiber research group of the Institute for Textile Technology of RWTH Aachen University. Each of us having a different academic background and bringing his specialization to our company. And together we have a combined experience of more than 20 years in the business. And to accomplish our goals, to accomplish our mission, we have gathered a team of great talents that continues to grow. And finally, I can only say we are really looking forward to getting in touch with you, finding solutions for your fiber and monitoring solutions. Thank you.
Ladies and gentlemen, CarboScreen, thank you so much. Wonderful. No, no, no. Okay, come back. It's okay. You come, but come on back. You can go off if you want to. It's kind. No, there are questions. Just have to stand here and listen to them. Right, Florent, you have a question.
Yes, yes. Thanks very much for the presentation. Two questions actually. The sensor that you are developing, it's proprietary, or are you using building blocks from other technologies outside?
Both. So there is a sensor that is not that was developed in the public funded project, but we also have sensors that are or will be protected by patents.
Okay. And second question, it's linked to the first one. What do we expect as a mix between hardware and software in your revenue stream in terms of top line between licenses and sensor sales?
Yes. So on the one hand, of course, hardware, these sensors. So we will not develop sensors in the sense of a sensor, but we will take sensors that are available on the market, combine them, and use them, and adjust them to the specific production process. In the first place, of course, carbon fibers. The software has to be customized to the needs of the requirements of the customer. And then we will have a licensing system for the software. Yeah.
Okay.
Got another 45 seconds. Enough time for a question and an answer.
Yeah, maybe you're describing that with your solution that there will be a cost benefit. You said speed is enhanced, but you're detecting defects already. So actually you have to eliminate them. How does that work?
Okay, so first of all, you can see that with a different setup of our sensors, the second sensor that I presented will be more on on the side of the exothermic reactions. If you use this sensor, you can directly see, okay, my process fits for the product, for the precursor I'm processing, or I have to change something. Otherwise, fiber could back out, or the oven could explode. And the optical sensor, you can see, okay, my material is not suitable for the processing, and I have to maybe change 5 or 6 fiber toes.
Okay, that's why I'll stop it there. Only 2 minutes. Ladies and gentlemen, you're all grooming a good way to start this session. Please put your hands together for CarboScreen. Well done. Thank you.
Thank you.
So there you go. Quite simple, isn't it? Quite simple to follow. 5 minutes, 2 minutes, walks off, listens to the questions before walks off, and then we can move on to our next startup right now. So we started in Germany. As I said, this is a global startup tour, right? So we this morning we were in USA, Germany, Italy, Korea. Right now we start in Germany, and now we move over to Greece. Please welcome to the stage our next startup, simply called Componous.
Welcome everyone. Gather around as we discuss how Componous aims to revolutionize the embedded optical fiber sensing in composite materials and beyond. Composite materials are well known for their lightness, strength, and reliability, but they require predictive maintenance, which increases downtime and undetected failures. Critical applications from pressure vessels to carbon crane masts require continuous monitoring of physical phenomena such as pressure and strain. Embedded sensing is the answer to those requirements, reducing downtime due to maintenance. Now, you might be thinking about traditional sensors like strain gauges, but they are bulky and complex. Miniature footprint optical fiber sensors, such as fiber bra gratings, are well known for decades, waiting for their moment to shine. But here's the catch. The technology to read this optical fiber sensor usually costs a fortune. Just imagine integrating an optical fiber grating into your composite for some euros, only to be blindsided by the 50,000 euro for a readout unit. Our solution aims to revolutionize the market. An optical fiber sensor interrogator priced below 1,000 euros with state-of-the-art performance, matching or surpassing the competition. In Componous, we offer a vertically integrated scheme, positioning us as a one-stop shop for complete sensing kits, merging software, hardware, and complete support. Our site is in the booming CFRP market. And also aerospace composites, with their heavy reliance in embedded sensors and advanced sensors, which is a $2 billion market. We are also targeting in optical fiber sensor market, where our low-cost interrogator stands out in a $1 billion field. By also tapping in more cost-sensitive markets, such as smaller bridges, safety tests, battery packings, agri-tech, and smart city systems, and by penetrating into those markets only by 0.1%, we aim to have a revenue for more than 25 million euros. Our interrogator has already found traction in low-cost UAVs for structural health monitoring, in sailboat masts for 3D shape sensing, and we are in front of a breakthrough in a different sector in defense, in submarine batteries monitoring system. Feedback from Photonics West in San Francisco confirmed the disruptiveness of our solution. Our interrogator is a game changer in smart material technology. In composites, we go from predictive maintenance to condition-based maintenance in a timely and data-driven manner, which decreases downtime, increases infrastructure lifespan, and improving product sustainability. Our team is the core of our company. A perfect combination of photonics, electronics, and composites expertise, ready to give complete sensing solution in many sectors. In our next steps, we're seeking to grow. We want to expand our team to evolve the next generation of our product, to expand our business, to scale up our production, and of course, enhance visibility. Join us in leading the revolution of embedded optical fiber sensing. Thank you.
Ladies and gentlemen, hands together for Componous. Fabulous, wonderful. Let's hear from our jury members. I believe Rebecca from Techstars is about to ask a question.
Thank you so much for this presentation. You pointed out that your competitive advantage is the cost. So interrogator 5 times more affordable than existing ones. Could you tell us more?
Exactly. This nice question. It is at least 5 times more affordable than the competition. Right now, the competition, we have tested many interrogators. The cheapest one cost 5.5K. And it does not have the technical characteristics that we provide with our solution. For example, the resolution is 15 times less than ours. So in order to have the resolution of our solution, we have to go up to 60,000 euros. So this is our advantage, yes.
Sorry. Very interesting presentation, thanks. I mean, quick question. How do you describe your business model? Is this an equipment sale or is this something else?
Okay, thank you for the question. Our business model is we want actually to have a one-stop shop for the sensing needs of composites and not only composites. We began with composites, but we want to have a complete sensing solution according to the client's needs. So we are application-oriented. I have to say that in order to have a photonic system for sensing, you have to speak with hundreds of suppliers. We want to have a vertical integration system and give sensing kits. So if somebody wants to sense temperature, we have the temperature kit. If somebody wants to sense pressure or hydrogen permeability, we can also have a kit for his needs, for the client's needs. Thank you.
There we have it, ladies and gentlemen. Once again, hands together for Componous. Well done. Thank you so much. Wonderful. There we are, already on our second, that was our second startup. Again, you're going to see, like we've just seen right now, all very diverse, all very different indeed, which makes it even more tougher for our jury members at the end of the day to pick a winner, to pick who should walk away a winner of this category. Remember, one from the other category, and there's one from all 20 finalists, which will walk away a winner as the best sustainable solution. Let's move on to our next startup right now. Please welcome to the stage, and this is actually from the Netherlands, in fact, Eddytec.
Good afternoon. My name is Alina Khanaeva. I'm a scientist and entrepreneur, and I turn cutting-edge technologies into products. And this is the reason why I co-founded Eddytec. Oh. Apologies. Eddytec is on a mission to transform defect detection in carbon fiber composites to make it faster, simpler, and help you save cost. And that matters in a number of industries. But today, I would like to talk to you about the aviation industry. We all know that flying has to become more sustainable. And one effective way to reduce CO2 emissions is by making the planes lighter. That makes sense. Less weight, less fuel used, less CO2 produced. And a great example of that is Airbus A350 that consists of 53% of lightweight carbon fiber composites. And compared to earlier models, Airbus was able to reduce the fuel consumption by 25% per seat. And currently, only 20% of all planes are new generation airplanes like A350. But over the next 20 years, firstly, the number of planes is going to double, and 95% of those planes will be new generation. To ensure the safety of flying, extensive checks are being performed on a regular basis and also upon incident. And those incidents are lightning strikes, bird strikes, and ground vehicle collisions. But currently, every plane the plane after an incident needs to be inspected. And currently, it is extremely slow, it is complex, and requires highly trained personnel. Wouldn't it be amazing if we could do that faster and simpler? And this is exactly what Eddytec set out to do. We're using eddy current sensor array to look for faults in carbon fiber composites. And it is as simple as taking this sensor, gliding it over the surface area of what you want to inspect, and look at the results. It is 10 times faster than currently used methods. It is extremely simple to use and can be easily automated. And also we can leverage machine learning to provide more in-depth information about the defects. So we've seen traction from quite a few industries, but especially from the aviation industry. And currently, we're collaborating with KLM Engineering and Maintenance to making their go, no-go decision faster. And the opportunity is sizable. Even if you look only at the aviation industry, maintenance, repair, and overhaul market is currently valued at almost 80 billion and is set to double over the next 20 years. 25% of that is airframe inspection and maintenance, and this is where our device is going to be used. 10% of that is global composite inspection. And considering that we'll be looking at the North America and Europe first, our opportunity is well over 100 million. What we're going to sell is a hardware device that requires almost no training to use, software that will help with data insights and simplified reporting. Our initial offering is aimed at go, no-go decisions. But further down the line, we will provide additional software that's based on machine learning. And it will help you gain additional insights that will be helpful in repair, R&D, and production optimization. But we're not only changing the game for planes. Our technology could help in production, maintenance, and repair of a variety of products. And just to show you a few, it can be wind turbine blades, sports equipment, cars, and hydrogen tanks. And this is the team that makes it possible. We are, as you can see, we are scientists, engineers, and seasoned professionals with background in physics, aerospace, and business. And we are driven by our passion for technology and product development. Now, you've seen what we can do. You've seen the potential of our technology. I would love to talk to you, independent of the industry, about how Eddytec can help you optimize your non-destructive testing. Please come up to me after that, or find us in the Startup Village. And I would like to talk to you about how we can take that further together. Thank you.
Ladies and gentlemen, hands together for Eddytec. There you go. Come forwards. Come forward. Okay. Is that that's the example? Maybe we can hand that over to the...
May I start with you? Here you go. That's this.
Okay, right. Let's move on to our questions now. I believe Florent has a question.
Yeah, thank you very much for the presentation. Extremely interesting. First question is, how much information do you need to have on the type of fiber composites that has been fabricated to make sure that you have the right detection? Is it agnostic to the type of process before that?
In principle, it's basically based on conductivity. So we would need to understand what is the material. So thickness, roughly the conductivity. So we will be adapting to a number of different types of carbon fiber composites. Then we will basically need to check which one is it, and then sort of say change to a certain setting or certain range that we can scan in.
Okay. And second question, quickly, the type of project that you're having with airlines, is it supposed to have a go-no-go decision totally automatized, or is it just intermediary step to have then validation through other non-destructive controls?
So currently we're looking at, so our very first step is validation for a specific use case. I think automation is not a challenge for us at all. We just give it to someone with a robotic arm, and that even helps us to position, because right now we are in charge of positioning, of finding where our sensor is. With a robotic arm, for example, will be even easier, so we can skip something.
Okay, thanks.
Maybe one question. Fantastic, actually. I'm looking for the but.
Yes.
Do you find the same defects in the same quality as reference solutions like ultrasonic solutions, for example?
So right now, we can basically translate the real life with our sensor into a 2D plot. So we can tell you, is there a change in conductivity, yes or no? So in-depth comparison with the ultrasound method, this is something that's on our roadmap. I hope that answers the question.
30 seconds on the clock.
Yeah, maybe. Do you find porosity? Do you find delamination or disbonds, things like that? And locate them as correct as we need them?
I guess my question would be, what kind of defects are you looking for, where they are, and where do we need to find them? So this is something that we are looking for partners to really define very well the use case, so we can tune our technology toward us. We can change quite a few things. We are in control of our hardware, depending on size of the coil, some electronics. We can adapt this, and that will be kind of the product development. So this is the next step.
Okay, there we have it. 2 minutes is up, ladies and gentlemen. Hands together for Eddytec. Well done. Again, another intriguing project that clearly gets our jury members curious and certainly want to know more. Right, let's move on now to our next big idea here on stage at the Startup Booster competition right now. This is, in fact, so where have we been already? Greece, Germany, Netherlands. Now we go over to Italy, and this is for Elementag.
Hello everyone, I'm Francesco from Particular Materials, and today I would like to cover 3 things with you. So what's the problem we want to tackle, what's Elementag, and to conclude, just a few words about ourselves. So jumping right into it. The rising consumer awareness around ESG principles and the green transition and the new regulatory frameworks that are being discussed in Europe are driving an unprecedented demand for transparency and traceability. Today, companies must demonstrate that they're sourcing responsibly and actively trying to reduce their carbon footprint. However, industrial supply chains are often complex, non-transparent, and traditional track and trace technologies have some common limitations, leaving certain categories of products like raw material, semi-finished goods, and certain small or critical components without a robust end-to-end traceability solution. For this reason, we think that new solutions are called for. And so Elementag overcomes the main limitation of traditional track and trace technologies, such as NFCs, RFIDs, and QR codes, by being fully integrated in the items, being invisible to the naked eye, not altering in any way the functional properties of the materials that it traces, and most importantly, being processing resistant, so guaranteeing end-to-end traceability from raw material to finished product. These also goes nicely along with the blockchain-based solutions and digital product passports, filling the gap between physical and digital when it comes to, as I said, blockchain-based solutions. So with this in mind, what is actually Elementag? So just as we associate a set of information to the distribution of dots in a QR code or to the signal of an NFC, in the same way we can associate that information to the composition of a nanomaterial, which then becomes a sort of artificial DNA for products. To detect the presence of our markers, we decided to use the XRF technology, which allows a quick, on-site, and non-destructive analysis thanks to portable XRF guns, like the one you see here stylized in the picture. And so Elementag is quite versatile as a technology, applicable virtually to anything, so from raw material to finished product, from industrial component to artwork. And just to give you a sense of what we have tested already, either in our labs or with industrial partners, so we went from polymer processing with in-bulk integration, from ceramic and leather finishing via surface coating, to security in jet printing, and more upstream with tracing like critical raw materials for the battery value chain and precious metals. And so the market, as I said, is supported by strong tailwinds, both regulatory and consumer-driven, and is expected to grow double-digit in the upcoming years. And so we decided to focus first on those applications where our technology is actually enabling something new, not possible with the competing technologies. So this is how we envision our ecosystem. So in parallel with the physical tracers, we are developing a digital solution to smoothly collect and integrate the data that we generate, especially linked to the blockchain topic that I mentioned before. And in terms of business model, we want to have a modular approach. So depending on the use case, you might need to do the authentication on a regular basis and independently. So for instance, for internal quality optimization purposes. In other cases, you might need it just on specific occasions, like for anti-counterfeiting, for insurance or claim management. So in that case, we might go with an on-demand approach. And we are in charge basically of the authentication, not the client itself. As I said, we have several pilots up and running, and this year we're going to move to industrial scale with a couple of clients, one in the plastic space, one in the leather space. Just to give you also a sense of the numbers and volumes we're talking about, so the plastic one is going to be around 300 tons, and we just need around 100 kilos of nanoparticles to trace that. Similarly, it's less than 100 kilos of nanoparticles to trace 2 million square meters of leather. So this is to give you a sense of the extremely low concentrations that we're talking about to make the technology work. And so in terms of next steps, we're mainly looking for industrial partners willing to test, play, challenge us on the technology. And later this year, we're going to raise some capital with 2 objectives in mind. So one is scale up the production capacity. The second one is to automate certain pre and post synthesis process tasks that today are done manually. And so this is who we are. So we started back in 2017. We are Particular Materials, an Italian nanotech startup. We started by making functional nanomaterials for industrial application with our patented process. And we developed two other technologies in parallel. So one is a spin-off, circular materials, which focuses on the recovery of metals from industrial wastewaters. And now with Denora and Snam, we are developing a technology for the green hydrogen production that also works in supercritical conditions. So this is the team. It's a nice mix of scientists and business profiles that have worked both in the academia, multinational companies, and startups. And that's all from me. So thank you very much for listening.
Ladies and gentlemen, hands together for Elementag. Well done. Let's come forwards. Okay, let's hear how our jury felt about what they've just heard. Karl-Heinz.
So hello, thank you very much for your very nice presentation. I have one question for you. Is your marker system somehow limited to certain materials, meaning taking composite materials as an example? Would it be able to somehow mark the resin, the matrix, and also the carbon fiber? Or do you have a limitation in terms of detection? Or can you say something about that?
Yeah, so at the moment, we haven't found, let's say, any non-traceable matrix or substrate. So everything that we have done has been successfully, let's say, implemented. And we went, as I said, from raw minerals to plastic to metals to textile. So we have tried different substrate and different matrices. The only thing that we need, so we need to find a compatible marker that has, so we use the XRF technology. So we need to find elements that are not present in the matrix itself. And typically we work with around 15 elements in the lanthanide space, so in that part of the table. And we have always managed to find a compatible marker or a compatible family of markers for each of our customers so far. So we don't see major issues in that regard.
Thank you.
45 seconds on the clock.
Yeah, thank you for the presentation. When you're doing your forecast, what do you expect being the costs for clients, for example, for a bag? What will it cost to add Elementag to it?
Yeah, so the advantage is that we work at super low concentrations. So we're talking about like 0.03% in bulk, I don't know, 45 milligrams per square meter. So it's super low per item. And what we have seen today, and let's say the soft confirmation that we have for the industrial scale-ups that we're doing, it's an impact of around 0.3, 0.7% on the unitary price is something acceptable for our clients, and that's also something doable for us in terms of like costs, and so that's a potential range. Then it depends on each application, the choice of the element that we need to insert. Of course, the raw materials have different prices. So,
and that's it, ladies and gentlemen. 2 minutes is up. Please put your hands together for Elementag. Thank you. There we are, moving steadily through these big ideas. All very diverse, all very different. But again, it's our jury members and you can't see them from where you're sitting. From my position, they're looking down, again, still poker face, no idea what's going on through their minds. A few smiles, I'm not quite sure at all what's happening. However, remember, tomorrow afternoon, I believe at 3:30 on this stage, we will be revealing the winner of the first category this morning. This category right now, the winner of this. And remember, there's a third category, which is simply, third winner, should I say, best sustainable solution. If I was to ask you right now, so far, who would you choose as the winner of the best sustainable solution? Who would that be? Don't shout it out, just think about it. It might have already gone, it might be coming. Let's move on now to our next startup. Please welcome to the stage, from Germany this time, Fiberior.
Thank you very much for the short introduction and the opportunity to share our idea with you today. Terms like climate change, CO2 footprint, ecological disasters are just terms of the last and ongoing decade. To meet these challenges, we need to use renewable energies for energy storage and for transportation. And the question is, how can we safely do this? One potential solution is hydrogen, as it is the energy carrier of the future. to supply companies in Europe with hydrogen and to link Europe with the energy suppliers of the future, a project called European Hydrogen Backbone has been founded. Within this project, 28 countries and 33 infrastructure operators are working together to build up a network to support whole Europe with a 50,000 kilometer pipelines. Currently, the costs for this are quite inaccurate due to the fact that such a technology in this scale has never been built up and the technology is quite new. My name is Tobias, we are Fiberia and we have a solution for this problem. Our new pipeline system consists of a polymer liner which is wrapped up with thermoplastic composites. Currently, there's only steel pipelines on the market for hydrogen transport. Steel can easily be damaged when hydrogen diffuses into the material. Our new pipeline system and our material doesn't degrade with hydrogen contact and can withstand its pressure. This leads to the opportunity to have a reduction in the costs by decreasing wall thicknesses and also no need for high material price steel grades. Furthermore, we are able to operate our pipeline system with a high and dynamic pressure, which gives us the ability to use it as a storage device. In times of availability of regenerative energies, we can increase the pressure within the pipeline system to store energy. Later on, in times of high consumption periods, we can decrease the pressure and use it. With a regular steel pipeline, such a dynamic pressure profile wouldn't be possible. To get more into detail and give you a practical example, I brought you this. Imagine a pipeline system from Morocco to France with around 2,000 kilometers of length and a pressure difference of 250 bars. The amount of energy that could be saved in pressure within this pipe is the same compared to 280,000 Tesla battery packs, without the use of any extra space or rare materials for construction. Our pipeline system is made up of meltable fiber-reinforced polymers. This way, we can use state-of-the-art tape recycling processes and also go into downcycling process. I've now shown you a lot of benefits regarding our product, but how did we achieve this? First of all, we went to analyze the conventional process chain for manufacturing thermoplastic continuous fiber-reinforced composite pipes. We tried to figure out all the inefficient steps in this process, and by eliminating these, we were able to develop a new manufacturing method based on an in-situ melt impregnation process. We were able to reduce the size of this machine to integrate it in a conventional winding machine, and this gives us the opportunity to reduce the costs, the emissions, and the production time at once. We've already implemented our process in a laboratory scale machine. We've heavily tested it, and we have 2 patents granted for this technology. So what are the next steps and what's the future of our company? We're just about to get founded, and we are working on our first minimum viable product, which will be ready in the second half of this year. After this, we want to go in a Series A investment round to fund first pilot project and to scale up our production. Our market research predicts that we have to have this be done before 2030 to gain significant market share. So if I could convince you today, we're happy to work with you together and hopefully get in contact. Finally, any idea and also strong composites require a strong team. And believe me, I found them. Together with my teammates, Markus Kammler for all the financial and non-technical parts, and together with Jonas Bernhard and Jonas Rabe for all technical stuff, we are Fiberia. I'm happy to answer your question and getting in touch with you. Thank you.
Ladies and gentlemen, there we are, hands together for Fiberia. Great, take a stand there, that's right, and let's hear from our jury members.
Yeah, thank you very much, Tobias. You have described that you have a solution developed, but it's more super lab scale. What is the maturity and why are you convinced that this would work and that could economically work?
Basically, the technology is not lab scale. We are producing tapes in kilograms scale right now on our first production machine. The production head, or the unique selling point of our machine is that it's very small. It's just 950 millimeters in length. It can fit into the winding machine, and we're already able to produce thermoplastic tape out of it. And right now we are using a laser assistant system to do the tubes, but the machine itself is operational. We will have a second machine running in the end of April, which has a way higher production capacity, and if you want to know how good our material is, just visit by the startup booster. We have a lot of samples, so we can show you how good it is.
Yeah, thank you. How do you control the quality of what you're winding?
We have after our impregnation unit, we have a quality gate. We measure the thickness, we measure the width of the tape, and we do in certain amounts on the production process micromechanical analysis of the impregnation process. But we have a very stable production, so it wasn't a problem so far. But we have a quality gate after the impregnation unit, and this is special about us. We can give you for every millimeter of our produced material all data. It's completely locked. The machine is built up by us, and we have it totally interlinked with the customer's database, and we can serve you everything.
And there we have it. 2 minutes already. Ladies and gentlemen, hands together, Fiberior. Well done. 2 minutes. That was 2 minutes. 2 minutes can go so quick for some of us and so slow for others. I was thinking, actually, what could you do in 2 minutes? What can you do? You couldn't even boil an egg, could you? Could you boil an egg? Maybe you could. I don't know. Haven't boiled an egg. I wouldn't say I've never boiled an egg, but it's a long time since I've boiled an egg. But 2 minutes, very quickly indeed, and even 5 minutes to share your big idea, to get a conversation, isn't always easy. Let's move on now to our next startup. This is in fact number 6, so already halfway through this session. Please welcome to the stage right now, and this is actually from Germany, Holy Technologies.
Hi, I'm Moritz, co-founder and CTO of Holy Technologies, and we're setting the standard for sustainable and high-performance composite manufacturing. So the design of a composite component, usually requires a lot of engineering knowledge. You need a lot of understanding on simulation of those components, and you usually need numerous trials to get up to a final component. So this makes the entire development very expensive. Next to that, the manufacturing of those components usually is quite manual, or if automated, they're going for very cost-intensive solutions like AFP machines. Next to that, there is still no possible solution to create an upcyclable component for materials that you can reuse for a second life application within the same application. So we have developed a production system which is incorporating all of these problems by we're using one single continuous dry fiber that we're placing with a robotic process. Then we're infusing it with a recyclable resin system so that the component can be dissolved afterwards, after end of life, and we can retrieve the fiber and the resin system. So this is enabled by a machine learning enhanced software platform that not only accounts the structural performance, but also the manufacturing as well as the recycling of the process, and brings that down into a specific fiber path. So with this, we're able to bring down the development time massively, as well as we are optimizing everything for automation, resulting in a high cost efficiency. So how does that work? Basically, we receive a CAD file and a specification from our customer. We're developing the optimal fiber path, are already able to integrate holes or inserts, or already the edges, are then placing that with a robot system, with a robotic system. You see here that it's the head is actually 3D printed, so it's quite a cheap one. And then you end up with a final component that doesn't need any post-processing, as holes and so on are already coming out of the mold. So the final component is, compared to a pre-preg component, a traditional one, up to 50% cheaper, because we are able to reduce massively the development costs because we have a very high level of automation and we have zero scrap within the production process. It's also up to 30% lighter as we're able to optimize on fiber level rather than on ply level. And it's 100% recyclable because we can retrieve the fibers and use them for the same application again. So this is a platform technology, and we're addressing a huge market as we can basically produce any components. That's why we focus on the high-performance carbon fiber segment at the moment, on low-volume productions, proceeding to larger scale productions like automotive, aerospace, or the energy sector, and are then heading on for further materials like glass fiber, aramid fibers, or natural fibers. We're currently focusing on the medical industry and are running some small series here, as well as in the motorsport industry, but are quite open for special opportunities that we can build together with you to sell, to provide some small series of components. So until the end of this year, we are able to produce around 200 components a year for one series, up to 2 meters in size. Then we're able to increase that to 500 units next year, and from 2026 on, we'll start tech licensing with more than 1,000 components a year that we're selling. We have a very strong team. So my co-founder, Bosse, has a background in venture building, so he has built his own companies before. I myself spent some time at the production at Airbus and developed composite components there. And then we have a strong expertise with a team of, in total, 9 people that are having deep expertise in simulation, robotics, software development, and from the business perspective as well. So now we're looking to increase our production volumes. So that means we're looking for small series together with you. So if you are having any type of components, primarily carbon fiber, that are, let's say, maximum around about 2 meters in size, primarily flat geometries, then we're happy to work together with you. And we're looking forward to making your product cheaper, lighter, and more sustainable. Thank you very much.
Ladies and gentlemen, there we are, Holy Technologies. Fantastic. If you'd like to come forward, I'm going to ask you to stand just there. That's right in the center. Fabulous, just there. Wonderful. Let's hear from our jury members.
Thank you for a very good presentation. Could you elaborate a bit on the recycling? Because I understand you print them, but if you then later dissolve the resin, what do you do with the fiber in the same process? Because some would be cut.
That's the thing. So we're not cutting the fiber at all. That's the entire design of the process. So that's how we enable this recyclability. As we're already incorporating holes, we can even introduce loads into holes, which is typically not something you like to do with composites. And so we're designing everything, also the edges. So we're having certain loops and so on, so that we're not cutting any edges, not any holes, nothing. So the fiber remains uncut, and we can extract it. And we've done it a few times for several components, that we can extract it and build the same component again.
Okay, understood. What is the limitation of the process in terms of design? Yeah, so what can you do and what not?
Yeah, so at the moment we're focusing on simpler components, so flat geometries. That's the focus for now. We're developing that based on complexity criteria, so we're adding features that we incorporate step by step. At the moment, as I said, primarily flat components. That's the thing. Yeah, so that's the focus at the moment.
There we have it, ladies and gentlemen. Hands together for Holy Technologies. Well done. Thank you. There we are. There we are. Right, on to number 7. This is the 7th big idea, innovation, game changer, perhaps even the winner. We might already have our winner. I don't know. You don't know. Maybe our jury members, they don't know, but collectively they will by tomorrow, and you will as well. Remember, 3:30 on this stage, we'll be sharing with you who walks away a winner of this category, the other category, and remember, best solution, best sustainable solution as well. Let's move on. Number 7, this is from, we don't go anywhere, in fact. This is from France, in fact, and it's Moby Scrap.
Hi, my name is Eric Louver, and I'm the CEO of MobiScrap, a startup which was created initially to recycle e-scrap, electronic scrap, but we found out that our process is very suitable for composite recycling. As you all know, the composite industry has a massive recycling problem. There are some existing solutions, but which can extract So again, the composite industry has a massive recycling, as you know, problem. There are existing solutions, but which can extract little value, like landfilling, incineration, or fine shredding. And there are some emerging solutions which can recover the value of fibers, but often they come with a high cost and some non-negligible environmental impact. So what we bring is a purely mechanical solution. And we do not try to separate fully the resin and the fibers. We try to produce fiber bundles which can be used afterwards as a reinforcement in new composites. To achieve this, we create enormous impacts with accelerations and decelerations up to 5,000 Gs and an impact every millisecond. This process, mechanical process, has many advantages. First, it's really low cost, low OPEX and low CAPEX. It has no thermal treatment, no chemicals, so it's purely electricity consumption with a low environmental footprint. Our demonstrator is already at industrial scale with a 1 ton per hour capacity. In 2023, we have made more than 50 successful tests with many different kinds of composites, and we could achieve fiber length of up to 100 millimeters for glass and 30-40 millimeters with carbon. We have tried many types of resins, thermosets, thermoplastics, and fibers. It can be unidirectional or woven. We have even made tests with prepregs or polymerized composites, and even with some other materials like metals, foam, wood, etc. So sourcing is not a problem because, as we could see this morning, discussing with many players in the industry, a lot of companies have problems with the recycling of the production waste in particular. So our focus will be on production waste because it's an easier material. We know exactly the composition. On carbon composites because that's really where the value is, but at the same time, glass composites is also a very attractive market due to its size. So the idea, you see pictures of the fibers or the fiber bundles, if you prefer, that we can obtain with our process. We can then reintegrate them in composite through various technologies, BMC, SMC, or injection. And we have started to do this. And with BMC, we have produced some parts, and the mechanical properties of these parts which were produced were very good. And actually, it's a way not only of recycling the fibers, but also the resin, which remains in these fiber bundles. So we need less resin to produce new composites. To produce new products is one thing, but to do it economically is another one. So this is not really a P&L that you can see on the slide, but the CapEx is very low for 1 ton per hour, so 3,000, 4,000 tons per year. The CapEx is €1 million. The OPEX is only about 250, and we are still discussing this, and actually we are at the beginning of this journey. We think that we'll be able to sell these recycled fibers with a price of maybe €1 per kilo for glass fibers and up to €10 per kilo for carbon fibers, which is 5 times less than virgin fibers. We have a great team and invite you to come to discuss with Christoph, so the inventor of the technology, Alex, and myself on our booth. And our strategy, that's the call to action slide. We want to create a dedicated entity for composites this year. So we invite investors, strategic investors, to join us in this adventure. We count on partnerships, first of all, to validate the use and new applications that can be developed with our fibers, and also to manufacture and to market these new products, which is something quite new for the industry. So we'll have to convince the industry that these fiber bundles can be really economically and with good performance reintegrated in new composites. And in terms of business model, we are open to joint ventures or licenses with different options on geography, sectors, etc. We are quite open on this. Thank you for your attention, and sorry for the slides problems that we have at the beginning with the slides.
Ladies and gentlemen, hands together for Moby Scrap. Not your fault at all. Technical problems, they happen. Right, stay there. Let's hear from our jury members and let's dig a little bit deeper underneath Moby Scrap. Let's find out.
So, Eric, congratulations on managing some technical issues. It's never easy, right? Question for you is, I mean, when you're processing the fibers, how much resin do you actually remove? Do you know what the resin content is at the end?
Yes, actually, when we did the first test with the client, he wanted to recover the resin. And they were quite disappointed because we found out that the resin content in the fiber bundles, if you want, is a bit lower than in the input, but not substantially lower. So it really depends on the types of, with prepregs, for instance, we have very, very little resin. We are essentially mechanically separating the fibers bundles. With polymerized, yes, we have about 5 or 10% of very fine powder. So it's essentially resin, but also with a bit of carbon and very tiny fibers. But at least 80% is this fiber fraction.
I mean, for me, it's always great to see a technology that looks relatively simple. Do you have patents, or is it trade secrets that protects the technology?
We have a patent, actually, and it's not only a matter of patent, it's also of know-how, because my partner, Christophe, who is the inventor of the technology, has developed it over years with the various generations. And just to give you an idea, the rotor, which is we create this acceleration between the rotor and stator, is a part with a weight above 1.5 tons, with a rotation speed of 1,500 RPMs. So you can imagine, there was a picture, we have a 250 kilowatt electromotor, so there are huge mechanical constraints, and it's not so easy to deal with.
Ladies and gentlemen, hands together for Moby Scrap. Thank you so much. Wonderful. Thank you.
Thank you.
Right, there we are. And again, remember every single one of our 10 startups in this session, and remember our 10 startups from this morning's session as well. You're curious about them. You like to know more. You doubt most things they say. You like to challenge them, or you just simply you're curious enough to have a conversation to want to know more. Or maybe in your network you know someone that might be a fantastic fit for this startup. Meet them at the Startup Booster Village at the entrance of this hall behind you, and that's where their booths are. Grab a coffee, grab a snack, have a chat, and then take those conversations forward as well. Let's move on to our next startup. Please welcome to the stage from Spain this time, Reinforce 3D.
Good afternoon. This is Blanca Garro, CEO of Reinforce 3D. We all know that each extra kilogram in the air has its consequences. The point is, the future of mobility will look like this. It may be because I'm sure that many of you would like to have one of those for Christmas. But what I do know is that this airlift has shell carbon fibers parts like this one, and also additive manufacturing topology optimized parts like this one. But as you can see here, this is metal, because how we could do these kind of parts with composites, that's almost impossible. Well, here I must tell you that exists a 3D printed composite market that is growing on a rate of 38%, and we want to take part of it. But this sector, and many companies that work on it, all of them, same as composite sector, keep on thinking layer by layer. With this approach, we cannot get a part topology optimized in composite like the one that we saw before. Well, here I must tell you, stop thinking layer by layer, and let's go beyond cell-like structures and composites. I introduce you the solution. Well, the video is not working. Well, our technology continuous fiber injection process. We are basically injecting continuous carbon fibers inside of a part. For that, we need a part with tubular cavities, which allows us to place continuous fiber in any required direction. Afterwards, we inject the carbon fiber with our injectable fibers using a resin as a lubricant. And once it's cured, we get our parts reinforced. Imagine all we could do with a technology that allows us to place fibers, continuous fibers, in any required direction, that we can also use it as an integrally joined technology, so different parts join with the fibers, capable of using it in large structure, any material. It doesn't matter if it's metal, polymer, or even ceramics, and no mold is required. Do you want to see an example? Well, take this satellite support structure. Here you have the original one, and for sure, a topology-optimized additive manufacturing one in metal. And we realized at Reinforce 3D that metal was not needed in the whole structure, just where the fixation points are. The rest of the part could be polymer, and all integrally joined with our fibers from end to end. The result, 70 weight reduction from the original one and 45 weight reduction from the already topology optimized. And cost reduction of 60%. Those are our numbers. I'm sure that you would like to try this on your shop floor. Well, the good news is that now exists a machine that is called Delta and is the first ever CFIP machine. From Reinforce 3D, we supply the Delta machine together with all the supplies like the injectable fibers, together with the resin and other supplies for the injector. And we also help our customers with consultancy services for engineering and manufacturing of the first units. In the near future, we will have software applications to support our customers during the design, simulation, and validation phase. Who could be our customer? Well, basically any application that requires lightweighting and strength, from aerospace and defense, automotive industry and racing, sporting goods like cycling, manufacturing fixtures and robotics, architecture, and mobility healthcare applications. And here you have few examples of companies that are already trusting on us. Our team, well, who is making this happen? Here I should start by our CTO and inventor of the technology, Mark Crescenti, who together with the whole team, including myself as CEO and our partners, we're making happening. And we want that for CFIP to become a state-of-the-art technology. But the journey hasn't been easy. From the time that this technology was just a project in a research and development center, to having found our startup, to having finalized our product by the end of the last year, to now being capable of delivering the first units to our early adopters. We want on 2025 to be open, to have general availability, be open to market. But in order to do that, we require funding. Funds for or to increase our personnel, to have investment for our production line, the software, and new research and development version of the machine. So even if you're an investor or who wants to be partnered with a great company or clever ideas, please contact us.
There we are, ladies and gentlemen, hands together for Reinforce 3D. Wonderful. Take a stand just there. Wonderful. Okay, let's find out more. Let's hear what our jury members felt about what they've just heard.
Thank you so much for your presentation. If you were to say the roadmap that you have from a product development point of view and also commercial point of view.
Yeah, I mean, from the machine, I mean, our main product is the machine and the supplies. Right now, we have developed the first version, which is the one that you saw. This is basically is a full automatization of the process, but it's still a bit manual. For example, when you want to inject a part, you still have to do it manually to connect. And if we would like to go into a really industrial version, we would like to put this injector on top of a robot arm, which makes it a fully industrial version. So when we have production on a scale of parts, then the robot knows how to inject on big scale, or maybe inject few few at the same time, like 2 rods at the same time or even more. That's what we would like to achieve in the future.
Hi, what is the price of the machine currently?
That's a really good question. Well, I don't know if I should answer that question right now, but right now it's in an early adopter version, and we are offering it around, let's say, less than 100K. For sure, right now we are talking about an early adopter version, which covers other teaching and services and how we make our customers capable to use the technology.
And there we have it, ladies and gentlemen. Hands together for Reinforced 3D. Well done. Congratulations.
Thank you very much.
Fabulous. Right, we are, guess what? Believe it or not, we are now on to our 9th out of 10, number 9, our 9th big idea of this second session of this Startup Booster competition. Looking for a winner. Only one of 10 walks away a winner from this session today, and we'll find out that tomorrow afternoon. But let's move on right now. Number 9, this is a startup from France, TechnoCarbon Technologies.
Hello, thank you for having us here. We've all dreamed of better materials, advanced materials that are at the same time more resistant to corrosion, thermal fatigue, or creep, and can deliver better performance for more affordable costs. And you might think that this is not possible, while at the same time addressing the many dimensions of the sustainability issues and challenges. However, I'm proud to announce that at TechnoCarbon, we have harnessed the power of nature by binding the oldest materials, stone, with with a space era innovation, carbon fiber. And this has required several years of research, and we've published several patents. And this, in turn, delivered a unique manufacturing process that enables getting the best of both the old world and the new world under the form of a multi-layer laminate composite made of stone and carbon fiber stone. It has the built-in corrosion and cracking protection mechanisms that other materials don't have. And on top of the ideal parameters for structural elements, it also has the 5 dimensions of the sustainability issues, meaning that we are using less constrained materials, and we use less energy intensive to make this material, and also can deliver lighter elements, and at the same time require less transportation. And finally, deliver near to zero maintenance due to extended lifetime. And this has been demonstrated in several testing campaigns in the lab and in the field, like this one at CSTB, where we show that stone is a flexible material that has, in fact, when it is reinforced with carbon fiber, becomes an elastoplastic material with very high resistance to creep and dynamic fatigue. So the market is huge because it is a worldwide market. But before that, we need to focus on our backyard, which is Europe. And in Europe, inside Europe, we can obtain a small share of the market in a few identified market segments that I will describe later, and grow our business so that we can reach the multiple hundred millions of dollars per year revenue scale by 2030. Of course, this requires us to prove that we obtain better performance while at the same time a much better sustainability record. And we've started doing this by obtaining some metrics, which are a factor 2 improvement for energy consumption while manufacturing, lighter elements up to 3 times lighter than their steel or steel reinforced concrete equivalent, a much longer lifetime, at least 5 times, and sometimes much more, and also immediate greenhouse gas emission reduction by at least a factor 10, and eventually going further. So we're in the process of obtaining the certification for this. So we've crossed phase 1 thanks to our pioneer customers. We are starting to address the second phase, which is basically the steel market with the steel manufacturers and steel builders. And the third phase will be tackled in the next few years because we're already working on large accounts and large construction phases. So what we will do in the future, of course, we will improve the sustainability record by going to carbon neutrality and eventually carbon negativity. And we've already started doing this by using biomass-based carbon fiber, which is still experimental, but we're seeing the first industrial plants built a couple of years ago and the second one this year. So this year, what we're doing is building our first manufacturing plant, a very small experimental facility. And in the future, what we'll do is expand this factory, then replicate, and then eventually move to licensing to grow worldwide. Our first demonstrator is installed at the camp near Aix-en-Provence in southern France. It has been built on a protected natural site.
I'm going to have to stop you. I'm sorry, I'm going to have to stop you there only because our 5 minutes is well over. Ladies and gentlemen, please put your hands together for TechnoCarbon Technologies. Would you like to come to the center here? Just come and stand here.
Sure.
For the questions. There we are. Take a stand there. Right. Let's find out from our jury members about what they've just heard.
Cool. Thanks for the presentation. Super interesting. I mean, for me, always the question is going to be, how do you look at the difference in scale between, let's call it the construction industry and the carbon fiber industry? There's not enough carbon fiber to service the construction industry. So how do you think about that from your business model?
Yeah, that was a question that we were asked early on. So we went to discuss with the carbon fiber makers, and then we've discovered that they're waiting for the carbon fiber market to expand because right now it's too small. It's only a few 100,000 tons per year, and they have already the plans of those large 100,000 ton per year factories. So if you talk to people like Toray or SGL, this innovation would be welcome because that's exactly what they are expecting to scale up carbon fiber manufacturing.
And you didn't say very much about the process. How do you actually manufacture it?
Yeah, the process is the simple laminate composite. So one layer of stone, one layer of carbon fiber fabric, and then curing. We use a little bit of resin, of course, and then curing, and then these binds. This is the picture that you've shown: 2 layers of stone and 1 layer of carbon. So the regular manufacturing process. The innovation that has been patented is that the way we do it enables a perfect transfer of stress between the carbon fiber and the stone. So that's the key.
Cool, thank you.
And there we have it. Happy? Yes, absolutely. No more questions. Good, all happy. Thank you so much. Please put your hands together for TechnoCarbon Technologies. Thank you. There we are. TechnoCarbon Technologies. Right, we move on now to actually our final startup, final big idea of this session right now. Let's hear it from our last startup from Korea, 3p.com.
Hi, I'm Sung-ha, CEO of 3p.com. Our main business is to develop and commercialize the cost-effective recyclable Type 4 hydrogen storage tank. Hydrogen-powered transportation, such as the vehicles and trains in UAV airplane, is significantly growing all over the world. And 6 million hydrogen tanks will be produced every year after 2030. The market of a hydrogen tank will reach $30 billion by 2035. However, today's hydrogen storage tank faces some challenges. Well, here is the issues. Let's briefly review our conventional thermoset wet winding tank. We start with a liner molding, and followed by the wet winding using winding machines. And then finally, we cured in a hot oven. Well, as you can see, each step is very costly and too costly to be sustainable, and also tank is non-recyclable. So here, I'd like to propose solutions. And first step, we developed cost-effective modular liner for hydrogen tank. Here, 2 end domes are just injected, molded, and then welded to a cylinder using our innovative thermoplastic welding, which can be well applicable to longer and larger tank. So this is called modular liner. And by this modular liner, the production cost can be reduced by 40%. Now, next solution is we develop robot-operated cost-effective ATLW, which consists of thermoplastic tape reel and laser welding system, which is called ATLW. And here we optimize the process parameters of a laser welding of a thermoplastic tape of the thermoplastic liner using the thermal imaging cameras. And so we significantly reduce the conventional ATL and the winding process cost to only 10%. Now we have a solution 3. We added digital twin robot simulations to scale up to a larger commercial size tank. Here it shows the entire procedure of a 52-liter tank, which is a fully digital robot operated. This is exactly the same spec as the Hyundai Nexo hydrogen tank. Okay, so you can see this is our final tank. So compared to conventional thermoset tank, our new thermoplastic tanks are pretty much sustainable. And first, we start with a modular liner, and then use robot laser welded thermoplastic tapes. That's it. We don't need any other post-processing or oven heatings. So price-wise, very sustainable, and tank is recyclable. And technically, it's very important. The inner liner is a thermoplastic, outer tape is a thermoplastic. They are perfect welded, unlike the thermoset wet winding. So our current partners and customers, so we work with several resin suppliers, and we do research and develop technology and supply technology and licensing to several companies in Korea, India, Taiwan, and Japan. We also look for the future customers. So here are the teams. 3P.com is one of the university startup and strongly supported by the Hanyang University. They offer 750 square meter space. So we've been a startup for the last 3 years. We develop technology. And me as a CEO, and we do have a CTO and CFO, and global marketing director, Alex Stranger. So here is our business roadmap. We made a game-changing breakthrough in the hydrogen storage tank, and our technology will apply to many different applications. Thank you so much.
There we are, ladies and gentlemen, hands together for 3P.com. Wonderful. If you'd like to come forward here, come forward. We'll have some questions. It's on, it should be on. It's on, absolutely. Just stand there, my friend.
Okay.
Wonderful. Let's hear from our jury members.
So hello, thank you very much for your nice presentation. And I have a question for you. You explained a lot about a new manufacturing process. Are you also able to support your customer in designing and simulating the development of a fuel cell tank?
Yes, sure. Actually, we start with the design, with the customer's specification, such as size and volumes and etc. We consider material property, whatever resin and carbon fibers. We design, we manufacture, we do a burst test ourselves. I didn't have time to show the burst test, but it's a complete set. And then once we convince, we provide to our customers.
Okay, thank you.
Thank you.
Another question. All happy? Are we happy? Yes, we are. I'm getting, what question? Yes?
What is the time that you're using to manufacture such a tank? I mean, you do in situ consolidation, which slows down actually quite the process.
Yes, we are targeting like the 2 to 3 hours for a 52-liter tank. But currently we are using just one tow, and which now it takes a little bit longer than that. But we plan to have a double tow preg. With that, I'm sure we can achieve the 2 to 3 hours of process.
And there we have it, ladies and gentlemen. Hands together for 3p.com. Well done. Congratulations. Thank you so much.
Thank you.
There we have it. Believe it or not, that's it. We have just listened to, experienced, jumped into the worlds of 10 all diverse big ideas in this category. If I was to choose a winner, it would be really tough for me to choose, probably for you as an audience as well. But again, you don't have to worry about that because you're not going to choose anything. That's where our jury members come in. They will very, very shortly, straight after this, move off to I don't know, a cave somewhere here in JEC. Well, we have no idea. It's a secret location. We don't know anything about it. They go in there blindfolded. They have no idea either. And they will discuss, they will debate. And then tomorrow, remember, here on this stage at 3:30, we will find out, discover, reveal the winner of the first category that we had this morning and the winner of this category, plus the best sustainable solution as well. So I'm intrigued as much as you are really to hear who those winners are. All that leaves me now to say, just before we finish, is a warm thank you to our jury members, to Chris, Rebecca, Florent, Karl-Heinz, and Jelle, they've given up their expertise, their knowledge, but most importantly, their time as well. And for you as an audience member, I'm sure whatever element or whatever area of composites you're in, it's kind of cool to see the diversity of this industry and maybe learn something new about other parts of the composite industry from a different perspective as well. Ladies and gentlemen, that is the end of this session, and we'll see you tomorrow on this stage, 3:30, to find out the winners of the Startup Booster Competition 2024.